Okay, so we're going to move on a little bit more and talk some more about medians and right bisectors, which we touched on at the end of the previous lesson. We're going to do a little bit more of them today. So just to remind yourself here what a median and a right bisector is, a median right here you can see in the picture, it's a line that joins the vertex or corner or endpoint of a triangle to the midpoint of the opposite side. So for example, here you've got a line going from this point, this vertex right up here, and it passes through the midpoint of the side across from that. Okay, and if you have a right bisector, well, that line's perpendicular to a line segment and passes through the midpoint. So you notice that it doesn't necessarily pass through any of the vertexes here or any of the corners of the triangle, but we have it going through the midpoint of one side perpendicular to it. Okay, and the other thing you can note here is that every point on the right bisector, so every point along this blue line will be the same distance from both endpoints of the line segment. So that means, you know, a point right here, for example, is going to be the same distance from this point as it is from this point. That's going to be true for any other point on that line. If I'm here, for example, it'll be the same distance from this point to here as it is to here. Okay, so with that in mind, you'll notice here that because a triangle here, looking at medians, a triangle has three corners, three vertexes. You can actually have three different medians inside this triangle. You can have a median from this corner, or from this corner right here. And similarly, you can do the same thing over here. Since the triangle has three sides, you can have three right bisectors, one that's perpendicular to each of these three sides. Okay, so what we're going to look at today is what happens when you try and find all those medians and right bisectors and see what happens when they actually intersect with each other. Okay, but first let's recall a few things from grade 9. To find the equation of a line, what are the two things you need? Well, you always need the slope of the line. That's number one. And you also need a point it passes through. Now, it could be the y-intercept. If it's a y-intercept, you could use a slope-intercept form, y equals mx plus b. But you can actually find it with any point you want, because if you have any other point, you could find either find the y-intercept, or you could put it into point-slope form right here. So if you haven't done much with point-slope form there, that's what it looks like. So you have y equals m, which is your slope, bracket x minus x1 plus y1. And in this equation, just to remind yourself here, m is your slope. Okay, and x1, y1 are just the coordinates of any point that's on the line. Okay, so no matter what the point is that's on the line, you can create a point slope form. So just to practice here, let's say I'm giving you here a slope and a point. So I want the equation of a line that passes through the point negative 7, 8 with slope of negative 5 over 9. Well, here I have my slope, here I have my point. So taking this form right here, let me just write it out. Okay, so I have my slope, that's going to be negative 5 over 9. I need to pass through the point negative 7, 8, and that right here, is, since it's a point on the line, will be my x1 and y1. So I'm going to have x minus negative 7 plus y1, which is 8. So just to simplify that here, because I don't want those two negatives together, I'm going to have negative 5 over 9, x plus 7 plus 8. And this would be a perfectly valid way to write out the equation of a line, and potentially a little bit faster in finding slope-intercept form. If you want slope-intercept form, you could do what you did back in grade 9. You could start with y equals mx plus b. Okay, you would sub in your slope for m and your point for x and y. So I put in 8 for y, negative 5 over 9 for my slope, negative 7 for x. And then my only unknown is b, and I could rearrange the equation and solve for b. It's a little bit more work, but it would give you slope-intercept form. The other thing you could do if you really want slope-intercept form, you could take this equation right here, the one I already created for point-slope form, expand it and simplify, and you get slope-intercept form as well. So I'm not going to do that, but that's a couple ways you can get the slope-intercept form. But in general, point-slope form is faster, so I'd recommend that we get used to using that. It'll save us some time down the road. Okay, so today we're going to look at a couple different questions. So the first one I'm going to give you is, I'm going to give you that triangle ABC has vertices at these 3 points. I'll give you the coordinates for A, B, and C. I'm going to ask you to sketch the triangle and label the points. I want you to find the equations of all 3 medians. Okay, so you're going to find all 3 of those medians, find the equations, basically doing what you did at the end of last lesson. Then you're going to find the point of intersection between 2 of those 3 medians and check that this point satisfies the third equation. If this is true, if it works out that the point of intersection satisfies the third equation, it means all 3 of these medians will intersect at the same point. Okay, so I'm going to have you do that, and when you finish that, I'm going to have you do the exact same kind of idea, but with a different triangle. I'll give you a triangle PQR, I'm going to have you sketch the triangle, but instead of finding all the medians, I'm going to have you find all 3 perpendicular bisectors. And again, same idea from there. Find the point of intersection between any 2 of them, and check that the point of intersection satisfies the 3rd one. Okay, so there's a lot going on here. These take a little while. I'm going to have you try them on your own first. There's a lot of work involved. But what I want you to do is, again, start with the triangle, start by labeling the points, and then try and find your medians and your points of intersection. So take a few minutes and try these on your own first. When you're ready to run through them together, push play and we'll go through them. Okay, just so you can check your first median here, again, I asked you to find the equations of all 3 medians for this triangle. To remind yourself how to find a median, I drew the triangle here, and I'm trying to do the median from A. So I'm going from A, negative 212, to some point out here I don't know yet. So remember, the median passed through the midpoint of the side across from it, so I have to find the midpoint of BC. So I do that over here. I have negative 10 plus 2 divided by 2, which is negative 4, and 4 plus 8 divided by 2, which is 6. So my midpoint there is negative 4, 6, which I've labeled right here. And now I need to find the slope of the median. So I'm going between the point A and that midpoint, which I just found, negative 4, 6. So I find the slope there, 12 rise over run, 12 minus 6 over negative 2 minus negative 4, to give me a slope of 3. Okay, that gives me, now for my median, if I have my slope, it's 3. My point's at negative 4, 6, or I could use a point at negative 2, 12. It doesn't actually matter. So if you did use that, you'd have a different answer. But if you're using the point negative 4, 6, you'd have y equals 3, bracket x plus 4 plus 6. If you use the point A for your median, which you obviously could have done, you would have had x plus 2 plus 12. Okay, either of those is fine, but that would be the equation of the median from A. So if you're stuck on the medians, that's how you can find that one. And again, now you can try and find BC and the points of intersection. Okay, if you'd like to check your other medians, for my median from B, the midpoint of the side across from B was AC, so the midpoint was 0, 10 when I calculated it. When I calculated my slope from B to that midpoint, I got a slope of 3 over 5. Since the midpoint happened to be the y-intercept, I know the y-intercept of that line, so I'm going to have in slope-intercept form y equals 3 over 5x plus 10. Okay, and lastly for the median from C, so I drew it over here, and I'm trying to find the midpoint of AB. The midpoint happens to be at negative 6, 8 once I calculate it. So if I try to find the slope here, you'll notice here that my y value is not changing. It's going from 8 to 8, so my rise is 0, my run is 8, but my slope is 0, and that tells me it's a horizontal line. So you'll see what happens if I try to create the equation. I have y equals 0 times bracket x plus 6 plus 8, so that 0 times that bracket here makes everything go away. So I'm just left with the equation y equals 8. So after all that work, I now have the 3 medians. Now you can see in my picture they seem to all intersect at a common point over here, and that's the point I'm trying to find here in part C. Trying to find that point of intersection. I'm just going to call it P for now. So since I have 3 equations here, we're used to doing points of intersection with 2 equations, 2 unknowns, not with 3 equations. What we're going to do is we're just going to take any 2 equations we want and find the point of intersection there. So you get to choose which ones you want to work with. Me personally, when I go through this in the video here, I'm going to choose what I think are the 2 easiest ones to work with. So I'm going to choose to take this one, y equals 8, because that one looks very easy to work with. And I'm going to choose to take this one up here, the median from A, the 3 bracket x plus 4 plus 6, because there's no fractions in it. If you prefer not to deal with brackets, you want to deal with the purple one, that's fine. But I'm going to choose to work with 3 bracket x plus 4 plus 6 as one equation, and y equals 8 for my other equation. I'm going to try and find the point of intersection between those. Okay, so again, if you haven't done that yet, try it on your own, and push play and you're ready to go through the answer together. Okay, so to find my POI here, I use substitution. So I have y equals 3 bracket x plus 4 plus 6, and then y equals 8. Just copy those equations down from up here. Now, I decided to sub y equals 8, because I already have y equals 8 over here, to put that in equation 1. So I replaced every y in the first equation with 8. And then I just had an equation involving x, so I just had to rearrange the equation and solve for x. So I expanded here to get 3x plus 12 plus 6, simplified to 3x plus 18 on the right side, subtracted 18 from both sides of the equation here. Again, I'm just trying to solve for x here. So I've got 3x equals negative 10, x equals negative 10 over 3. So that's the x value of that point of intersection. Now, normally your process was when you're doing substitution elimination all the way back in Unit 1, you take your answer and sub it into one of the original equations to find your other variable. In this case, though, we actually don't need to do that here. So you see I didn't have to sub it into one of the original equations because, remember, one of my equations already tells me y equals 8. So it doesn't matter what I put in put into that equation, like if I'm putting in the right x value into here, it's just going to give me y equals 8 anyways, and I already have that from one of my equations. So to save yourself some time here, don't bother going through that step. We already know y equals 8. So that gives me my POI here at negative 10 over 3, 8. And again, just looking at what I was solving for, this was the median from C and the median from A, and I'm just seeing that they intersect there at the point negative 10 over 3, 8. Now, to check to make sure that the POI is also the POI for the third equation as well, see if they all intersect at the same spot. Now, I could go through the long way and actually solve another system of equations involving the median I haven't used yet, the purple one here, but it's not necessary because as long as this point, negative 10 over 3, 8, is on that line, I know it's going to be the point of intersection because it's going to be a point that shares in common with all the other ones. So instead of going through the whole process of substitution or elimination again, I just need to do, like it says here, check that the point of intersection satisfies the third equation. Okay, so that's what I'm going to do down here. So if it satisfies the third equation, when I sub it in, I should get left side equaling right side. So I'm going to take my median from up here, the 3 over 5x plus 10. This is for part D here, just checking to see that my POI satisfies the third equation. Okay, I'm going to take my POI here. I'm going to sub it into a left side, right side check. So the left side of my equation is y. The right side of my equation is 3 over 5x plus 10. And again, I want to see that I'm going to get the same thing when I sub in this point into both the left side and right side of the equation. So x is negative 10 over 3, so I put that into the right side here. So I get 3 over 5 times negative 10 over 3. Plus 10. Okay, so I put that into there. And then for the y value, it gets replaced with 8. So my left side is nice and easy. I just get y equals 8. For my right side, I have to do a little bit of algebra here just to clear it up. So I wind up here, if I multiply, I get negative 30 over 15 plus 10. Negative 30 over 15 simplifies to negative 2. So I get negative 2 plus 10, which is 8. Okay, so what I've done here is since left side equals right side, I've proven that this point, negative 10 over 3, 8, in addition to being the point of intersection between the two medians I solved for up here, is also the point of intersection for the third median as well. So this point right here is the point where all three of those medians intersect. Okay, so the three medians of a triangle will always intersect at a common point. So just to summarize here, the point of intersection of the medians of a triangle is called the centroid, and the significance of that centroid is that it's a center of mass or balance point of the triangle. So if you can picture yourself creating this triangle with the exact dimensions that you had up there, if you were to find that centroid, calculate it, this would be the point where you could balance it on your finger. Because again, its center of mass is where it's going to balance in the triangle. Okay, so in our particular triangle, that point of intersection, the balance point is going to be at the point negative 10 over 3, 8. So if you want to take a look here, here's a triangle with just the medians drawn in. So you can see they're always going to intersect at a common point no matter what you do with the vertices of the triangle. So again, each triangle does have a balance point or a center of mass, and you can always find it by finding that point of intersection between all the different medians. Okay, so now I want to do the similar process, but we're going to do it with right bisectors instead. Okay, so again, if you're not sure how to look up how to do right bisectors, look at the previous unit, look at lesson 10 that we went through the other day. But if you're not sure, again, try it on your own first. I'll go through one right bisector with you so you can be on your way and give the rest of it a try. But give it a try and push play and see the answer. Okay, so if you want to check your first right bisector here, if you're not sure how to go through one, I first started with the bisector of QR. So remember, a perpendicular bisector, it's perpendicular to a line segment, passes through its midpoint. So it doesn't necessarily have anything to do with a vertex or a corner of the triangle. So for QR here, I know it's going to pass through the midpoint, so I tried to find the midpoint here at M. So I did that here. So halfway between Q and R would be 4 plus 1 over 2, negative 1 plus negative 2 over 2, which gives me a midpoint of 5 over 2, negative 3 over 2. Now I also know that's perpendicular to here, so perpendicular means the slopes are negative reciprocals of each other. So again, I now have a point for that this line passes through. It's the midpoint, but I need the slope as well. So to find the slope, I'm going to find the slope of QR first, which I did here. So rise over run. I have negative 1 minus negative 2 over 4 minus 1 gives me a slope of 1 over 3. Now because my right bisector is perpendicular, I take the negative reciprocal of that slope, so my slope is going to be -3.